Welcome to the Chemistry, Biology and Math Revision Hub. Today we're doing the Pearson Edexcel International A-Level Chemistry Unit 1 for January 2023. Let's begin with the first question. Question 1 says, which compound contains 2.35 times 10 power 22 molecules in 2.5 grams? So they've given us Avogadro's constant. The molecules of this are going to be the mass divided by the molar mass times Avogadro's constant, and it gave me that. For this one here, I got that. For this is 2.5 divided by 64.1 times that, I got that. And this, I did the same thing, 2.5 divided by 80.1, and I got that. So C was my answer. In the next part, what is the concentration of hydroxide ions in a solution containing 5 grams of barium hydroxide in 250 centimeters cubed? 1 mole of barium hydroxide, when it breaks, it produces 2 moles of hydroxide. Since we know the mass, number of moles of barium hydroxide is going to be mass divided by molar mass, giving me this. And that means the number of moles of this are going to be twice that, which is that. So the concentration is going to be these moles into 50, which is the number of moles divided by the volume, and the concentration gave me that. And here D is my answer. Moving on. Question 3. A sample of 15 grams of vanadium reacted completely with 7.07 grams of oxygen. What is the formula of the oxide? Since we're given the atomic mass of each, the number of moles of vanadium are going to be 15 divided by 50.9, which is that. And the number of moles of oxygen are going to be that divided by that, which is that. Calculating the mole ratio, I got 1 to 1.4994, which is about 1.5. So multiplying by 2, I got a 2 to 3. And therefore, the compound is going to be V2O3, so it's going to be B. Question 4. What is the pressure when 5 mole of nitrogen in a container with a volume of 1.5 meters cubed is heated at 500 K? I use the formula PV is equal to nRT, where R is given, P is equal to N divided by V times RT. Everything is given to me in the right unit, so 5 times 8.31 times 500 divided by 1.5, it gave me 13850 pascals. So this is approximated to this, and C is going to be my answer. Question 5. Which is the equation for the reaction of magnesium chloride solution with sodium hydroxide solution? If these two solutions are reacting, a displacement reaction is going to occur. Sodium is more reactive, so we will form sodium chloride as well as magnesium hydroxide. But the formed magnesium hydroxide is going to be a solid, so the answer is going to be a B. This would be okay, but here they said aqueous, so that is wrong. So the answer is going to be B. This is an ionic equation for that reaction. Moving on. Question 6. How many neutrons and electrons are there in gold? We can see gold 2 plus, 190 and 79. So we can see the number of electrons are going to be 79 minus 2, which is 77. And then we can see the number of neutrons are going to be 190 minus 79, which gives us 111. So the answer here should be that, which is A. In question 7, the mass spectrum of an element is shown. We have percentage abundance on the vertical axis and the mass to charge on the horizontal. They ask what is the relative atomic mass of this element. Now, I first added everything to find out if the total abundance is going to be 100. So this is 60 plus 18 plus 16 plus 6, and I got 100. So I know the total is 100. So now the relative atomic mass is going to be 60 divided by 100 times 90 plus 18 divided by 100 times 91 plus 16 divided by 100 times 94 plus 6 divided by 100 times 96. And adding up everything, I got 91.18, which is approximately 91.2, and the answer is a C. Moving on. Question 8. Which is the equation for the second ionization of element J? Remember, it's second ionization, so J is already a gaseous ion of +1 charge, so meaning gaseous ion of +1 charge being converted to a gaseous ion of 2 plus charge by the loss of an electron, so the answer should be a B. In question 9, which is the reason why fluorine has a higher first ionization energy than oxygen? Fluorine has more protons than oxygen, so the outer electron is going to be held more tightly, and so it's going to be hard for it to be ionized. So D is the correct answer, it has more protons. Question 10. which is the electronic configuration of chromium. Chromium has 24 electrons, so the configuration should be this. Moving on. Question 11. Which combination of ions would be expected to form the compound with the highest melting temperature? The highest melting temperature is going to be in a smaller cation with a high charge. So considering the high charge first, strontium is below magnesium, so this one is smaller. And then it's connected to oxygen, which is smaller than sulfur, so we can see the answer is going to be B. Question 12. Which is a use of graphene based on its electrical properties? It's going to be used in touch screens, so C is the answer. Question 13. Which molecule has the largest bond angle? When we look at boron trichloride, bond angle is 120. CO2 is going to be linear, bond angle 180. We can see water is going to be bond angle 104.5, and here bond angle 107. So we can see 180 is the greatest bond angle, so the answer should be B. Question 14. Which molecule is polar? Of course, we can see this is going to be nonpolar, symmetrical. This is nonpolar, there is symmetry. This is also nonpolar. It's only this one that is going to be polar, so the answer is going to be A. Moving on. Prop 2-in-10 is flammable, toxic, and an environmental hazard. Which hazard symbol should be shown on its container? This is the hazard symbol for flammable, that is for toxic, and this is for environmental hazard, so the answer should be A. And by the way, please remember how to draw these hazard symbols, because in the most recent papers, they're asking questions about drawing these hazard symbols. I know this one is not included in your textbook as well as this, but try to find out which one means what and how to draw them. At least I've seen a question about this, about that. Also, oxidizing can be asked, so try to make sure you know how to draw all these hazard symbols. So moving on. Question 16, which is the skeletal structure of 3,4-dichloro-2,2-dimethyl-pentane. Now, because the structure is pentane, I began by drawing 5 carbons. 1, 2, 3, 4, 5. I chose my carbon 2 to put the 2 methyls. So if this is carbon 2, the 2 methyls are there. And then on carbon 3, there is going to be a chloro, and on carbon 4. So this is similar to that. You can see if this is carbon 1 and carbon 2, we have 2 methyls. We have a chloro on carbon 3 and a chloro on carbon 4. When you look at this one here, there is a chloro and a methyl. They cannot be on the same carbon, so this is out. This is also out, and that is also out. Chloro and methyls are not on the same carbon, so this is going to be my answer. So down here, question 17. What is the name of a series such as the one shown? This is an alcohol, 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 so we can say it's a homologous series. The answer should be C. Moving on. Question 18. Which is not a step in the reaction of chlorine with propane in ultraviolet radiation? This is possible. This is a termination reaction. That is also termination. This is propagation. This one will not occur, so the answer is D. In question 19, why does free radical substitution have limited use in industrial chemistry? The atomic economy may be lower and the yield could be lower because there are other products that are going to be produced. So the answer should be C. Further substitution products are formed, and this is going to lead to a lower yield. So that is not beneficial to industrial chemists. In question 20, which molecule can exist as E and Z isomers? When I sketch this out, you can see there is no higher priority group here around the carbon-carbon double bond because this carbon has 2 similar groups. Also around this carbon-carbon double bond, you can see similar groups. Now, when we compare this carbon-carbon double bond, you can see on this carbon, this group as well as that group are the same, meaning there is no higher priority group here. And again, to show you again, no higher priority group here, no higher priority group here, no higher priority group here. But when we look at this, we can see this carbon here contains this group as well as hydrogen, and that carbon here contains that group and hydrogen. So this is the only one that can be a geometric isomer to BEZ. So this brings us to the end of section A. Let's continue to section B. Question 21. The structure of a compound X is shown. X is present in Petro. So they say give the molecular formula and IUPAC name of X. So I'm going to try to remove this so that you can visualize. So this is my structure X. We can see it has 1, 2, 3, 4, 5, 6, 7, 8 carbons. And since it's a hydrocarbon, the general formula is going to be carbon N, hydrogen 2N plus 2. It's going to be carbon 8, hydrogen 16 plus 2, which is hydrogen 18. Now for the name, because this is the carbon with more groups, I'm going to call this carbon 1 and that is carbon 2. So we have two groups here. So carbon 2, carbon 3, carbon 4. So we have a 2, 2, 4 trimethyl, and then the main chain is a pentane. Okay, I replace that. The next part says, name the industrial process used to form X from the straight chain isomer. The industrial process is reforming because this is a branched isomer formed from a straight chain isomer. In part B, heptane is also present in petrol. Write an equation for the complete combustion of heptane. Include state symbols. Heptane is carbon 7 hydrogen 16. When it burns in oxygen, it produces carbon dioxide and water. When we are balancing a combustion reaction, we begin by carbons. Since there are 7 carbons here, put a 7 on carbon, and we see there are 16 hydrogens. Put an 8 to create 16 hydrogens. After we balance the carbons and hydrogens, then we can balance the oxygens. Now the oxygens here are 14 plus what we see here, which is 8. 14 plus 8 creates 22, so I just have to put 11 here to create 22 atoms of oxygen. And for the state symbols, this is a liquid. You know, carbon 7 is a liquid. This is a gas, that is a gas, and that is a liquid. The next part, identify by name or formula a pollutant that may result from the incomplete combustion of heptane. This could be carbon monoxide. Moving on. In part C, recently, sales of electric cars have increased. Give two environmental benefits of using electric cars and justify your answer. Electric cars do not emit carbon dioxide, which is a greenhouse gas, and they do not emit other pollutants like oxides of sulfur or nitrogen that could lead to acid rain. So this brings us to the end of question 21. Let's continue to question 22. Question 22. This question is about propene and some related compounds. Some reactions of propene are shown. So we have reaction 1, propene to propane, that is using nickel and hydrogen to cause hydrogenation. Then propene to product A using chlorine, that is going to be a halogenoalkane. Then propene to propan 2O, this is going to be a reaction with steam in the presence of phosphoric acid as a catalyst. And then propene using potassium manganate, which is acidified, we create a di-O, which is product B. Now in part 1, they say, identify by name or formula the catalyst needed in reaction 1. This is a hydrogenation reaction, we need nickel catalyst. And they say name product A. You can see propene reacting with chlorine. We form a 1,2-dichloro, so 1,2-dichloropropane. Next they say identify by name or formula the substance needed for reaction 2. Reaction 2, we need steam and phosphoric acid, so that is the answer. Then the displayed formula of product B, which is a di-O, the double bond is going to break and OH groups are going to be attached on either side, creating product B. Moving on. In part B, propene can undergo addition polymerization. Write the equation for the polymerization of propene. Now, n numbers of propene molecules go through polymerization to produce this one here. I put n here. And again, to polymerize, the double bond breaks, which is broken here, and then you form extensions in that manner. In the next part, over 70 million tons of polypropene are produced each year. So they say state 2 problems with the disposal of polymers such as polypropene. These polymers are non-biodegradable, so they do not break down in nature, and they produce toxic gases when incineration is carried out. Moving on. Next they say hydrogen bromide reacts with 3-bromopropene to form 1,2-dibromopropane as the major product. Complete the mechanism to show this reaction. Include curly arrows and any relevant lone pairs and dipoles. So since the reaction is with hydrogen bromide, of course this bond is going to be polar. So this is partial minus and partial plus. The double bond breaks as electrons are donated to bond with hydrogen, and then this bond breaks to go away, creating a Br minus. So since we are looking for formation of a major product, we're going to have a major carbocation, and in this case this hydrogen is going to bond here so that this becomes the positive carbon. So we can see we have a secondary carbocation. And then in the next step, this is going to come here, so we can see Br minus coming to the carbocation in order to bind and form this product. So down here they say Explain why 1,2-dibromopropane is a major product instead of 1,3-dibromopropane. Same idea, this question comes a lot because the mechanism for the formation of 1,2-dibromopropane goes through formation of a secondary carbocation, and secondary carbocations are more stable than primary carbocations. So this brings us to the end of question 22. Let's continue to question 23. Question 23. Oxygen is vital in the treatment of respiratory diseases. Oxygen is traditionally produced by fractional distillation of air. Suggest one difference between the fractional distillation of air and of crude oil. When we carry out fractional distillation of air, we are not going to heat, but we could carry out cooling. So I said, to distill air, cooling must be carried out, while fractional distillation of crude oil requires heating. Next, they say, hospital patients sometimes need to breathe air with a higher than normal concentration of oxygen. The oxygen concentration can be increased to 90% by passing dry air through a tube filled with zeolite, which absorbs most of the nitrogen. Dry air contains 21% oxygen by volume. The average human breath has a volume of 500 centimeters cubed. They say calculate the volume of air in decimeters cubed that would have to pass over zeolite to obtain 500 centimeters cubed of gas containing 90% oxygen by volume. Volume per breath is 500 centimeters cubed. The volume of oxygen per breath is going to be 90 divided by 100 times 500 because we say it's going to be 90%, so which is 450. But since the percentage of oxygen in air is 21%, it means 21 over 100 times a certain volume is going to give us 450 because this is the 90% of the 500. So X is going to be 450 times 100 divided by 21, which is 2142.9 centimeters cubed. I converted it to decimeters cubed by dividing by 1000. It gave me 2.1429 decimeters cubed. Here they say, nitrogen molecules bind to zeolite using their outer electrons. Draw a dot and cross diagram of the bonding in a nitrogen molecule. They want you to show outer electrons only. When two nitrogen molecules bind, a triple bond is formed, meaning each of the nitrogens is contributing 3 electrons. Since a nitrogen atom has 5 electrons in the outer shell, it means only 2 electrons are going to be left, meaning those are the non-bonded electrons, but 3 of each are going to be bonded, so the structure should look like that. Moving on. In part C, liquid oxygen is transported across the world. Liquid oxygen has a density of 1140 gram per decimeter cubed. Calculate the volume of gas in meters cubed measured at room temperature and pressure that can be obtained from a bottle containing 13.9 decimeters cubed of liquid oxygen. So they've given us the molar gas volume, which is that. From the information given, the mass of oxygen is going to be density times volume. We know the density is 1140 times 13.9. So the mass is 15846 grams. And the number of moles is going to be the mass divided by the molar mass, and we get those moles. So the volume of gas should be number of moles times molar gas volume. The decimal place was here, but it's supposed to be here, so I've corrected that. But the rest is okay, so the volume of the gas should be moles times molar volume, which is this times that, giving us this. But that is in decimeters cubed. Converting this to meters cubed, I divided by 1000, and it gave me 11.88. You could also round it to 11.9 to give your answer in 3 significant figures, and that was my answer. Down here they say the total mass of the bottle is 80 kilograms when it is full of oxygen. Calculate the mass of an empty bottle using your working from C1 and give your answer to an appropriate number of significant figures. Now from above, we know the mass of oxygen is 15846 grams, which is 15.846 kilograms. When you divide this by 1000, you get that. So that means the mass of the empty container is going to be 80 minus 15.846, which is 64.154. Rounding off, it's going to be 64.2 kilograms if it's 3 significant figures. Then, explain why the container needs to have such a large mass. Now, you're transporting oxygen. It's going to be compressed. The large mass is going to enable for the container to withstand the compression. So I said since oxygen is compressed, the container should be thick to withstand the high pressure of oxygen inside it. So this brings us to the end of question 23. Let's continue to question 24. Question 24. The radii of ions of some successive elements in the periodic table are shown. So we see from nitrite to aluminium 3+. They say plot a graph of the data. So all I needed is to draw the graph, use an appropriate scale, place the labels as well as units, and try to put the points in an appropriate way, and that will be okay. So on the next page they say, predict the radius of magnesium ion using a straight line of best fit on your graph. So I placed my straight line of best fit, and magnesium is going to be something closer to that. That is why I get about 75, and that is the answer I placed here. So here I wrote 75 pm, acceptable values are within that. Then they say explain the trend in ionic radii from nitrite ion to aluminium ion. So these are all isoelectronic, so it means the one with the most number of protons is going to have the smallest radius. So here I said the ionic radius decreases from nitrite to aluminium 3+ because the number of protons increases, leading to an increase in the nuclear charge, yet they have the same electronic configuration. And down here, sodium and fluorine react to form a compound, state the structure and bonding of sodium fluoride. It's going to be a giant ionic lattice. Moving on. Explain how the electrical conductivity of sodium fluoride provides evidence for the existence of ions. Sodium fluoride contains sodium plus and fluoride minus, and when it's melted, the ions are going to separate. So the sodium ions are going to show up at the negative electrode, while the fluoride ions are going to show up at the positive electrode. So I said sodium fluoride does not conduct electricity in solid state because its ions are not free to move. However, in aqueous or molten state, sodium fluoride can conduct electricity due to presence of free ions. In the next part, explain why the fluoride ion is difficult to polarize. For an anion to be polarized well, it should have a bigger size and a higher charge. But for fluoride, the charge is smaller, the size is smaller, so it makes its electron cloud closer to the nucleus and harder to be distorted. So I said fluoride ion has a smaller charge and a smaller size, so it is harder for its electron cloud to be distorted. So this brings us to the end of question 24. Let's continue to question 25. Question 25. This question is about aluminium and its compounds. State the shape of a molecule of aluminium trichloride, which is that aluminium trichloride has a shape similar to this, which is trigonal planar. Then down here they say aluminium chloride can exist as a dimer formed from two molecules of aluminium trichloride. Draw a diagram of this dimer showing the bonding between the two molecules. We have one molecule here and another molecule here, and there are two dative covalent bonds formed between the two molecules. One is shown here and the other is shown here. So the structure should look like this. And down here they say, aluminium trichloride reacts vigorously with water to produce hydrogen chloride and aluminium hydroxide. Write the equation for this reaction. State symbols are not required. Because aluminium trichloride is reacting with water, the products are that as well as that. Since we have 3 chlorines here, I have to put a 3 here to balance them. But when I do that, the hydrogens become 3 as well, and we have 3 others here, making them 6. So I have to put a 3 here to make the hydrogen 6 in order to balance this equation. Moving on. Aluminium trichloride also reacts with sodium hydroxide. So they say calculate the maximum mass of aluminium hydroxide. This is the mass we're looking for, precipitated when excess aluminium trichloride reacts with. So this is going to be excess. When excess aluminium trichloride reacts with 150 centimeters cubed or 1.5 mole per decimeter cubed sodium hydroxide. If this is excess, it means we're going to use the moles of the limiting reagent. So moles of sodium hydroxide will be the concentration times the volume, and these are all given here. So 1.5 times 150 divided by 1000. We divide by 1000 to convert this to decimeters cubed. It gives us 0.225 mole. And then the next part is to find the moles of this using these moles. The mole ratio is 3 to 1, so moles of these are going to be 1/3 times the moles of sodium hydroxide, which is what we see here, and I got 0.075 mole. Now next, to find the mass, I needed to first find the molar mass of aluminium hydroxide, which is going to be aluminium 27 plus each of these oxygen is 16 plus 1, that is 17 times 3. Total gave me 78 grams per mole. Now finally, the mass of aluminium hydroxide should be the number of moles times the molar mass, which gave me 5.85 grams as my answer. Moving on. In part D, describe the metallic bonding in aluminium. Now, metallic bonding aluminium, we have cations of 3 plus charge that have lost 3 electrons, and each cation can form 3 metallic bonds. So I said metallic bonds are strong electrostatic forces of attraction. In aluminium, metallic bonds exist between aluminium 3 cations and localized electrons. So finally, they say explain how metallic bonding leads to the properties of electrical conductivity and malleability shown by aluminium. These all occur because they are delocalized electrons. So I said in metallic compounds, when a potential difference is applied, the delocalized electrons can flow, conducting electricity. And also in aluminium, we know they are cations that are arranged in layers. When a force is applied, the layers slide past each other, held together by the delocalized electrons, and the structure can be reshaped. So this brings us to the end of this paper. Thank you for being with us. Do not forget to subscribe. See you in the next video. Bye-bye.